So just to point out, the last topic we covered was unit testing and how that's going to replace our simpler, just basic assert tests. They're great. They provide a nice, more systematic way of writing our tests, running our tests. We get much clearer reports of how our tests did, where they failed, what happened, what was different, etc. So the unit tests are far better than just the regular old, plain old assert tests that we were doing before. The spirit of what we were doing was the same, but they are different in how we write them. The syntax is different, and it's nice because we kind of group all of the required code for each test is self-contained in its own method. And yeah, there we go. All right, data structures. Here, let's have a look here. Yes. So data structures. You know, we've been dealing with algorithms a lot. I mean, every line of code we write is part of an algorithm. And a lot of times, especially for manipulating data, we're also going to need a data structure. And the data structure really, I mean, its name is pretty descriptive. It's just some structure that holds data. And we saw a couple so far. We saw lists. They're very general purpose. But we also saw like tuples, which were a little different. You know, they were like lists, but you know, you can index them, but they're immutable. Lists are mutable. We saw sets, and sets aren't as general as lists, but their power, when you need the features of a set, they're exactly what you want. They're fantastic, right? If I want to know, for example, the list of unique words in 2 books, you know, I can add both collections of words from both books to a set, and that's all the set will contain. It's great. It's not as general purpose as a list, but that's not the point of a set. And we also saw dictionaries. Dictionaries are phenomenal. They're a very different data structure. There's a lot more going on underneath than a list, but you know, dictionary, again, it's another data structure. These are all data structures. And at the end of the day, these data structures are all built with algorithms. They're all built with code. So like when I'm writing an algorithm that needs a data structure, great, but we're dealing with that data structure at a fairly abstract level. We're dealing with the list. We're not thinking about the underlying code that makes up a list, right? We're just interacting with a list object. Great. It's kind of the point of the object. It's the point of the data structure. It facilitates abstraction. It's great. You're not thinking about how exactly does something get added to the list? How does something get removed from a list? How do I actually index something in a list? You're not thinking about that, and that's fine. We're dealing with the list at a very different level of abstraction than the algorithms that we're writing ourselves. A lot of these data structures all had their own functionality associated with them. They also had some other benefits: ability to index, efficient lookups, easy to search, orderedness to the data, managing duplicates. Each data structure had its own purpose, right? Its own utility. Now, the list was very general purpose, which is great. Remember that. So consider lists. You know, we've been using these a lot. The lists have a beginning and an end. Right? There's a start to it. Here, let me do this. Oh, closed. That might help with the lighting. The lists have an index, and the elements in the list have an orderedness to it. Now remember, when I say orderedness, I don't necessarily mean sorted. I just mean the thing at index 0 comes before the thing at index 1, right? And the thing at index 1 comes before the thing at index 10. So there's an orderedness to it. And there's a beginning and an end. If I said go to the beginning of the list, you know what that means. With a set, it was a little different. I say, what's the first element in the set? And you go like, wow, sets don't really have an order, right? So that's kind of not really a reasonable question to ask. Elements exist in some order, yeah, okay. And it's easy to do a linear search on, very easy to do a linear search, right? You start at index 0. Does that contain the thing I'm looking for? Yes or no? Go to the next one. Does that contain the thing I'm looking for? Yes or no, etc. It's just a linear search. Great lists. We're familiar with them. If you dug deeper, if you thought to yourself, okay, how does a list actually work? And you open up the hood, you're going to see a lot more code underneath that we don't deal with directly, which is a good thing, right? We're dealing with it at a very abstract level. So, obviously, the fact that Python gives you a list, and look, if this is next semester and we're dealing with Java, Java has lists as well, okay? But we're not going to be using lists in Java from the start. We're going to be going to arrays, which are a little different, but they exist. Lists exist. And it's important to know how to use a list to solve problems, obviously. But at the end of the day, if you're learning, let me put it this way. Next semester, the course is called Data Structures, all right? It's a course on data structures. And so you're going to learn about lists. But I'm going to tell you next semester that you need to go solve these problems and you need to use a list, but you're not allowed to use the list that Java gives you. You have to build the list from the ground up. And then there's always some asshole in the room that goes, well, why would I do that? I can just import it. And it's like, because you're taking a course on data structures. It's like someone saying, you're taking a course on how they work and how to build them and how it's going. Imagine showing up to a course on how to build a car and then someone saying, why would I build a car when I can just buy it? Then go buy it and leave, right? You're learning how these things work. You're new programmers, you got to know how these things work. So we're dealing with the list at this level, but if you open up that hood and you look underneath, there's a hell of a lot more going on under there. And we want to start to learn what the hell is going on under there. The good news is, it's really not that complex. There's really no crazy, now when I say it's not that I don't mean it's trivial. That's not what I'm saying. I'm not saying you should expect to look at it and understand it. No. I'm saying there's no huge mental leap you need to make to understand these things. You already have all of the skills you need to be able to look under the hood and understand what's happening if you take your time and you go slow. So there's nothing crazy, new, wild stuff going on, no. But it does take time to understand. So yeah, actually understanding how they do what they do is important. So here's what we're going to do. A list is very general purpose, all right? But it's also perhaps a little bit more complex of a data structure. So we're going to make a very specialized data structure. It's not going to be a list. It's going to be very much like a list, but it's going to be a little bit different. And what we're going to do is we're going to make a data structure called a course. And the course is going to be a collection of student objects. All right? Before we can start building the data structure, we need to actually make a student class. Because we want our data structure to be a collection of students. And then if you ask, well, what's a student object? Well, we have to build it as well. So we're going to start with a plain old class. It's just going to be a student class. It's just going to store some data. And I don't even remember what functionality we have. Let's have a look. The student objects are the objects we care about, but the problem is we will have many of them, and we want a nice way to manage the students. So imagine imagine I want a program to keep track of my students in the course, right? So the students are the information I actually care about, but I need a way to manage those student objects. So I'm going to create a course object to store and manage the student objects. For now, we're going to focus on the student class. It's going to be a really simple class to keep track of important student information. And we're also going to define our important magic methods, our EQ and our repr. because they're just often handy in general. You usually want to implement them. I know I was saying before with the magic methods, there's a lot of them, and you only really implement the ones you need, but usually you're almost always going to implement repr and EQ. And to be clear, like another magic method is like a less than, underscore, 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 LT, underscore, underscore. And it probably doesn't really make a lot of sense to define less than for student objects. Maybe you can, if you wanted to like order them by grade or something, I don't know. But it doesn't really make a lot of sense. EQ, okay, there we go. Equality and repr, probably going to be handy. So let's start. Class student. And then we start with our initializer, our constructor, underscore, underscore, init. Self, first name, it's a string. Last name, it's a string. And student number, it's a string. Cool, that's all. That's all we've got. If you think to yourself, well, what if I also want to store, go ahead. It doesn't matter. Remember, you're inventing this now. When you are writing classes, you are defining what it means to be a student in your program. So even though I have only 3 attributes there, you could have as many as you want if you think you need them. There's nothing wrong with that. So don't think that the fact that I have these 3 is meaningful in any way other than the fact that I just picked them. Any questions so far? This is review, but it's review. So if you have any questions about what we're seeing, ask now before it's too late. All right. So, first name, it's assigned to the attribute first name. Last name, attribute last name. Student number, attribute student number. Great. And now we'll define EQ. There. First we check if other is even a student, something we could even compare to. If it isn't, we just ignore it. If it is, then we actually ask the question. But you'll notice this EQ is a little different than the ones we've seen before. This one actually only compares student numbers. Can anyone give me an intuition as to why? Yeah, so I could check if their names, their first and last name and student number are the same. I could do that check. But really, all that really matters in order for 2 students to be considered equal is if they have the exact same student number. It's not possible for 2 different students to have the same student number. Therefore, if I have 2 student objects with the same student number, they must be the same student. So you could check all attributes, that's fine, but for here, that's all I really need. Any questions about this EQ? And repr. You'll notice this repr looks a little different than the reprs I've written for the other classes as well. And that's fine. The convention I followed before, where it was name of the class, parenthesis, attribute, 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 etc., close parenthesis. Remember that was the pattern from before. But here, I'm just saying last name, comma, first name. Who remembers what /t is? Tab. Tab, student number. Why? Because I wanted to. Because here's what I'm thinking. When I print out my course, I just want a list of the names of the students. I don't want to see student, open parenthesis, blah, 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 blah. No. For my purposes, I think this is going to make a little bit more sense. Any questions so far? This is following the same pattern than from what we're used to. But, the EQ is a little different than what we've seen before, and same with the repr. So let's do a quick little test. A student this is obviously not unit tests or cert tests. I'm just doing some sanity check here to make sure it seems to be working. Yeah, I can make it. Here, in fact, I don't even really need to assign the first and last name. Pardon me for a moment while I silence my phone. There. There we go. So when I print out a student, I see Smith, Bob, their student number. Now if I check, what do you expect this to return based on the code I wrote? Why? Why are they not equal? They're not. They were supposed to be. They are equal. Okay, so you were wrong, but you were right. Or you were right, but you were whatever. Yeah.
False because it's the same student number, so therefore they're technically the same student.
But the question is, are they equal? So they are equal because they have the same student number. So if your point is, you probably shouldn't allow that though. You probably shouldn't have two students with the, yeah, you raise an interesting point. But for the purpose of how this is programmed, they are equal because their student numbers are the same. Even though their first and last names are different, that doesn't matter for this. If I were to go and change this to say and self dot, if I rerun that and now run it, well now it's false because the first names aren't the same. Okay, there we go. There we go. Cool. What else was I going to say about this? I feel like I'm forgetting. There was something I wanted to mention. Oh. Anyone want to take a wild guess? Oh, wait. Student number is supposed to be an integer. Oh, what's it mad about now? Oh, can't start with a 0. There. Cool. Maybe I should have made student number a string, though, not an integer. Anyone want to know? I mean, anyone want to talk? Let's take a moment and think. Why might I want student number to be a string and not an integer? Yeah, I see what you mean. That's not what I'm thinking, but you raised an interesting point, nevertheless. What were you going to say? Concatenate them easier. That's, that's true, but not what I had in mind. This is kind of a peculiar situation. It's student numbers can begin with a 0, but I can't have an integer start with a 0. It won't let me do that. That's really all it is. But there's some argument that maybe it should still be an integer because sometimes those student numbers, maybe they've got some checksums or something on it where you should be able to apply some mathematics to the student number to get some certain value that guarantees it's a valid student number, that kind of protects against BS student numbers, by the way. So whatever, not that important anyways. There we go. One thing to emphasize here too, even though this was specified in, now this is review, you should know this. This is from 2 months ago now. Even though the type hint set int, it never stopped me from making it a string, right? The type hint is just for the programmer. It doesn't make Python enforce anything at all. Cool. All right, any questions, any questions, any questions? All right. What do we have? Okay, our functionality defined magic methods, the main, yeah, notice that this particular class is very simple. It doesn't actually have any functionality associated with it other than the repr and the EQ. And you might think like, well, you know, is that really worth making a class? Yes, it is. Because I want to make clear something. Before, when I was saying classes are a great way for collecting data and functionality together. But maybe I should have been clearer, where it's a great way for collecting data together and or functionality together, okay? It doesn't necessarily mean data needs to go with functionality in the same class. This class, the student class, really is just storing data. It's storing student information, their names and their student number, that's it. There's no real functionality there. You could look at the repr and the EQ, yeah, but I'm not saying like update student, whatever. Like there's a lot of functionality, like I just could add, but I didn't add. Just because you can combine data and functionality doesn't mean you should. Now, this idea will be emphasized a lot next semester in the assignments and in this particular example. But I'm going to warn you, the exception to this idea, first of all, it's not a hard and fast rule. You can combine data and functionality. And to be clear, when I say combine data and functionality, I mean your class has a bunch of attributes, the data, and functionality, the methods. But if you have a class, you don't need methods, or you don't even need attributes. You can just have a bunch of methods associated with your class. That's fine. Or you can have both. It's fine to have both. But there's a lot of programmers that would say, you know, keep your data and functionality separate, right? Data is data, functionality is functionality. If you're saying to yourself, well, really, it really does make a lot of sense to combine this data and functionality. Well, maybe it does, but maybe you can make a design decision where you can still keep these things separate, which we'll learn more next semester. The big exception to this, though, where everyone goes like, well, yeah, you're stuck with combining data and functionality, is in data structures. When you create, for example, a list, you are like combining data and functionality. You're storing data, and you've got a bunch of functionality there, like append to a list, search through the list, sort the list, whatever, whatever, whatever. The course class, which we're about to do, is going to be a data structure. It's just a collection of student objects, and there's going to be data and functionality put together. All right? Okay, yeah, and here I was saying, okay, the first name and last name values may change for a student. Yeah, a student might update their first name, sure, but their student numbers need to be the same. Their student numbers won't change. And yeah, the repr does not follow the class name attributes format we've been using for the purpose of this particular program. I want it to look like this, because. And you'll see that when I print out the course, you'll kind of see what I mean. Okay, one last time. Any questions about this student class? So now, the course class. The course is going to be a collection of students. I mean, at the end of the day, it's going to be just like a list of students, but it's going to be specialized. So, yeah, all these students are going to be stored in a list, but we want to make use of a class to add specific functionality we care about. And we'll have the course class control access to the students through methods. And listen to this carefully for a second. The course class is going to be responsible for managing the students, okay? Not me directly, the course is. I'm going to ask the course to add students to it, for example. We'll have, the course control access to the list of students through methods. We'll have a method to add a student, remove a student, a method to get the size, and a method to check if a given student exists in a course. That's just going to be a linear search. Then we'll have a repr because it's good to have. We're not going to write an EQ because it's going to be tricky to write equality for students, or so for courses, and we'll talk more about that, I think, at the end of this topic. If I forget, someone try to remind me why EQ is difficult here. So let's start. There. We've got our constructor. Hold on. Yeah, we've got our constructor, but you'll notice this constructor only takes one parameter, the name of the course. So a course, one of its attributes is going to be what's its name. How many attributes does this course object have? When you look at this constructor, it should be clear how many does it have? 2. But it only has one parameter. But that's entirely fine. Some of the attributes' values for an object will not depend on any parameterized value. When I create a new course, it's going to be empty. When I create a new course, there's going to be no students in the course. So there's nothing really I could give it to set it up with. When I create a course, I'm going to give it a name, and then the course is going to create an attribute called students, and it is going to be an empty list. Because when the course is created, the course is empty. It's going to be a list of no students in it. What do you notice interesting about line 5? The underscore. This is actually a very important convention. Whenever a programmer sees an attribute that starts with an underscore, that means something. Now, Python's not going to enforce anything about this. This is just a convention. In the similar way where Python doesn't enforce that constants don't change, but if your variable is all uppercase letters, you don't change it. You leave it alone because that's the convention the programmers follow. So when an attribute starts with an underscore, that means that anyone outside of the class is not supposed to touch this attribute directly. I'll show you what I mean. This will be clear as we go, but if I have a student right? Attribute, first name. So first of all, this is the student class. First name, last name, student number. They're right there. Okay? You'll notice none of them start with an underscore. And then me, I am now outside of the class. This code I'm writing is not within the student class. No, it's somewhere else. And I'm creating a student object. And then from here, I can say, hey, a student, what's your first name? Right? This isn't weird. I can technically change it as well, though maybe you shouldn't. But all right, like I can change it, but the point is I can access this thing. If I go down here and I say a course, okay, and I say a course name, you know, I can do this, this is fine. But look, even Colab is trying to do me a favor here. Colab's doing code complete. And you will see that it's saying, well, there's only really one attribute there. Course name. And you look here and you're like, well, there's two though. What's going on? Well, yes, there's two, but the underscore means something. It means don't touch this. Leave it alone. You're not supposed to touch this. Let's hit pause for a moment. This idea of information hiding, the don't touch this, is very important. You might think to yourself as a programmer, well, I'm God. I'm writing my code. I can do what I want. If I want to touch this, I can touch this, right? I made that attribute. I can do what I want. Chances are, if I don't need to know about, if I'm using a class and I don't need to know about some underlying attribute, I don't need to touch it. Who can tell me what the underlying attributes are inside the list class? I didn't think so. You don't know, because you don't need to know. That information was hidden from you because you don't need to know. It has nothing to do with how you interface with the list class. It's all hidden from you. It's kind of this idea, that's the same idea here. I'm saying, okay, I'm making a course class, and yes, there's an attribute inside that's going to be a list of just a list. But no one's supposed to touch it. The code inside the course class can touch it. Anything inside the class, it's fine. But as soon as you take a step outside the class and you're writing code, like, for example, here, I'm not supposed to touch it. Now, I can, what was it called, students? I can access it. I can. Python won't stop me from doing it. But when I do this, I'm an asshole. I'm breaking the convention. I was not supposed to access this attribute at all. So that's what the underscore means. In other programming languages, like Java, that we will be hitting next semester, you actually have more control over this. You use words like public and private to distinguish between underscore and no underscore. Private would be the underscore. But when something's marked private, it's not a case, it's another case of like, well, in Python, well, it's a convention, but Python will let you break the rule. In Java, if it's private, it won't let you break the rule. If you try to access something private, it'll say, nope, I won't even start to run the code. There's an issue with your code. And that's good, because it's better to not have your code run when something's wrong with it than it is to have it run and silently break all the rules. Any questions about that? To be clear, at this stage, not critically crazy important that you have a full understanding of this. Just be aware. Yeah, you had a question?
If we aren't able to access the underscore students, how do we append students to this course?
Well, I'm glad you asked. We're going to see that very shortly. We're going to write a method that does it for us. Long story short. So here we go. All right, where are we going? Okay, yeah, above a constructor, the only two attributes. Notice student, the student's attribute, that's an issue. That should be a lowercase. That's a typo. Starts with an underscore. We don't really want to access the students directly, yada, yada, okay. As a convention to let yourself and other programmers know, all attributes and methods that are not to be accessed start with an underscore. So here is how we do exactly what you were asking. Add. How are we going to add a student? Well, here's how. We write a method for the course class called add. And all it's going to do is go to that student's list, and append to it. That's all it's going to do. But that's how I add things to the course. There was another one here, size. If I ask the course, how big are you? Just return the length of the student list. That's all that really matters. Cool. So for size, yeah, we're just hijacking the length. For add, we're just hijacking append. If you're looking at this and you're saying, okay, yeah, so this feels like a really roundabout way to append. Why not just say, like, underscore students dot append directly? Like, why are you making it more roundabout? And you're making a good observation. You're not wrong about that, but the point you have to know is, when you are interfacing, when you are using a class, whenever you use the list class, you are interfacing with the class. All right? Pretend for a second I'm like a gatekeeper. You're over here, and here is the list class, or the course class, whatever. And right here is a line. And I say to you, if you want to use this, this is how you do it. And you don't need to know anything that's happening over here, because it doesn't matter to you. Has it mattered to you up until this point how the list really worked? Or did all that really mattered was that the list worked? All that really mattered was that the list did what it did. The only reason it would matter how it worked is if you were curious and you were like, well, how does it work? That's what we're doing now, is how does this work? So right now, you're able to peek over and see what's actually happening at the back end. But you got to remember, you're really not supposed to know how the course class works in the back end. You're writing it now. I realize you're writing it and using it. I get that. But the point is, that's hidden from you. It doesn't matter to you. If you're using the course class, you don't give a shit how the course class worked underneath. If it works and it's correct, I can use it and I'm happy. So if you're looking at that and being like, but all that's doing is, you're already kind of breaking the spirit of this. The spirit is, it doesn't matter to you. Okay, the method to remove a student and check if the course contains a specific student, both need linear searches. Okay, yes. So if I want to write a method to remove a student, I need to, 1, find the student, and then 2, remove it. If I want to check if a student exists, well, that's just another linear search. So both the remove and what it contains require a linear search. Okay, so to eliminate duplicate code, let's write like a function that can be used in those methods to just do that common part, the linear search. But of course, this is a class, and classes don't have functions, they have methods. But the linear search method I'm going to write, the method I want to write to do a linear search, I don't really want anyone to access directly. I don't want anyone to do a linear search directly on the class. What I want them to do is ask the class, do you contain a student? Go remove this student. So the person using the course class shouldn't ever call linear search. No, they'll call remove. And remove will call linear search, or contains, and contains will call linear search. That's how I want this to work. So I want to write a method, find, I'll call it. And it's just going to do a linear search. But like the attribute, students, where I had it start with an underscore to mean you're really not supposed to access this attribute directly, I'm going to write a find method that starts with an underscore. But now this is a method that starts with an underscore, which really means you're not supposed to use this directly. You could, but you're really not supposed to. So let's go write that. So yeah, we'll write find. If the specified student is found within the students, return the index. If the student is not found, return a sentinel value of -1. I used the word sentinel value in the course before, right? It's just a fancy word to say it's a value that has a special meaning. Linear search returns any integer that's positive. I assume that's the index in which the thing exists. But if I ever see a -1, that has a special meaning. It means it's not there. There. So here's my find. I'm just going to loop over the students. If the student is equal to the student I'm looking for, then return the index. If I ever get to the end, return -1. And remember, how does Python know what it means for two students to be equal? Why would line, what is that, 15 work? Well, because I defined what it means for students to be equal right here, if their student numbers are the same. Any questions about this linear search here? One way I might change this a little bit to make it a little clearer is if I go there. I think this is a little better. Right? I created a constant called not found that has the value -1, but now the code's a little clearer. Most of the time, any other programmer would see something like this and see a -1 returned. They'd go, okay, obviously it's a sentinel value. But there's no harm in making your code that much more understandable. Cool? Questions? I really want you to ask questions if you have questions. It's boring just talking at you. All right. The find method's not particularly remarkable. It's just a linear search. But with find and remove, with find, removing contains become pretty easy. Here's a, for example, there. Here's contains. Except here, look. Here's another reason why. There. That's even better, I think. So contains. All contains does is call the method find. This method, find, it's private. It starts with an underscore, meaning I'm not supposed to access it from outside the class. But this isn't outside the class. This is within the course class. Okay? And because of it, it's entirely fine to access that method directly here. So all contains does is call find. And find will either return an index or return -1, not found. So if it ever returns -1, not found equals, not found will be false. This returns false. So this function will return true as long as find returns anything that's not -1. If it ever returns -1, that not found constant, then it'll return false, meaning it's not there. Yeah? No? Happy? Unhappy? And now remove. Have a look at this one. Yeah.
So could you write contains and remove if you didn't have the find?
I could. I would just have to basically put this functionality inside each of these things.
More work.
A little more work. This just kind of removed, because then it would be like duplicate code. I'd have to put this code in here and then in here. Now it's not duplicate. Yeah. Look at this remove. This is a little bit more sophisticated than what we've seen. It checks if that student doesn't exist. If I say, hey, remove this student from this collection, and it doesn't exist, what do I do? What should I do? It's like me telling you right now, well, okay, what were you going to say? Make an exception. Great idea. What gave that away? What do? Do you ignore it? Maybe. Is that a problem? Does that mean something went wrong in your code if you ever try to remove a student that's not there? I don't know. That's up to you. Whoever's using my course class, that's up to you. What do you want to do if you ever accidentally try to remove something that's not there? I don't know. All I can do is raise an exception. So I check, hey, if the thing's not there, raise the exception. Otherwise, I just say students.pop the index of where that thing is. .pop on a list, if you say .pop at a specified index, it removes the thing there. It just like removes it from the list. Cool. Any questions about that? Remove, contains remove, yeah. And then repr, you know what, we better stop here because I might want to talk a moment about repr. Any last questions? All right, I'll see you all later.